Here's a radiological survey meter, more commonly known as a Geiger counter. It's the Electroneutronics Inc. model CDV 700 6B. These were built for the Civil Defense Authority, which is was a part of the U.S. government, back in the mid-1960s. A bunch of different makers built these things for the U.S. government, and Electroneutronics was one of the smaller ones. Victorine was the biggest maker, but Lionel, the same company that makes the toy trains, also made some of these for the U.S. government. Those sell for a premium because Lionel collectors want them, and civil defense equipment collectors want them. I've had this thing for at least 8 years, if not 10 years. I forget exactly when I bought it. This particular unit here was new old stock, never been issued. It didn't even have the Geiger tube installed in it. I got one out of a dead Victorine 700 6B, and that got it to work, but the metering circuit was not working correctly. It was reading way higher than it should on this check source here. I just repaired it about 2 weeks ago, and it turned out that all this thing needed was some new electrolytic capacitors. There's a 200 millifarad capacitor that is used to sum up the pulses from the Geiger counter and drive this very sensitive meter. And that capacitor had gone way up in value, which was causing the meter to read way upscale. So replacing that solved the problem, and now the set works pretty well. I just attached the earphone here. This one's a little bit more comfortable than the ones that Victorine included with their sets, but it's still not all that great. The probe has a rotating beta shield. When it's open like this, the actual tube itself is exposed, and that allows it to pick up beta particles. It's not sensitive to alpha particles, so it only picks up beta and gamma. Now, when testing it, the manual says to set it to the X10 range and hold the probe with the window open up to the check source, making sure that one of the bars isn't obscuring part of the check source, which is, I believe, a piece of depleted uranium. Don't peel off that sticker, by the way. The check source is right underneath it. On one of these that I had sold previously, someone had done that, so I had to seal it over with a piece of packing tape so that nothing would escape. With the probe ideally positioned, I was getting it to read 0.2 on average, which is what the manual says it should be. This is not a powerful radioactive source at all. Each click you hear is an individual beta particle hitting the probe, and the amount of radioactivity being released at any given time varies. You can see the needle going up and down and the rate of clicks varying. Now this set will actually pick up just the normal background radiation that we have on Earth, which comes from both radioactive material in the Earth itself and cosmic rays from space. You'll just hear an occasional click if you just leave this thing running and set to the X1 range. Sometimes you'll get a fairly big burst. My understanding is that those cosmic ray bursts are from like a star that exploded many light years away, and obviously many years in the past, probably millions of years. I just think that's kind of neat. The outside design of these 706B sets was standardized by the government, as was the tube used in the probe and all that. But the internal construction was left up to the manufacturer. I'm assuming they got some guidelines, but the designs by Electroneutronics, who made this one, and Victorine, and also Lionel, are all different. This is the second rarest version. The Lionel version is the rarest and most valuable. It's a fairly simple circuit. This one just uses 3 transistors. The Victorine one uses only 2. I don't remember what the Lionel one uses. It runs off of 4 D cells, although you can see that they're in 2 parallel pairs. So it could theoretically run off of just 2, but if you leave the holders half empty, these metal clip things can come into contact with the circuit board and cause a short, so it's not a good idea. Here's my replacement capacitor. It's made out of 3 capacitors, because I needed to get exactly 200 millifarads, and I didn't have a suitable one at the time. That works fine though. Just not as attractive as a single one would be. Here's the high voltage oscillator section. Just 1 transistor drives this transformer, and then it's rectified with that high voltage rectifier there, because the Geiger tube in here needs 900 volts, or I believe actually 930 volts. Battery damage is fairly common on these, but since this one was never issued, the battery connectors are all in great shape. Here's the original manual. This machine was used for checking if food was contaminated, or if people coming back into a fallout shelter had radioactive dust on them. Thanks for watching.